Suppose I'm differentiating a power function. That is to say, I'm differentiating a function whose output is the form x raised to some power, and for a brief moment, let me just assume that power is a nice, clean, natural number. Going back to my definition of the derivative function, the derivative should look like this. The limit, as h goes to 0, of my standard Newton's quotient. Would that look like this? Now, I do have the mathematical legal right to make an assumption that you are all pre-calculus experts. And so for me to expand this binomial raised to the nth power, I merely dive in and use my binomial theorem. That'll give me these n+1 terms. Down to the last term, which looks like this. Oh, but there's a lingering minus x to the n at the end. Looks to me like the first term and the last term in the numerous position are going to cancel. Now that these two terms are eliminated, my goodness, I forgot my h factor. Notice how each and every one of these terms has a factor of h. As a matter of fact, there's one factor of h in the first term, 2 in the second, 3 in the third, etc. And if I factor in each out, I think what's left over from the first term is this. Now, what's left over from the second term is an expression involving only one factor of h. The next will have 2 factors of h, all the way down to the last, which will have n-1 factors of h. Bottom line, all the terms here, except for the first one, they all have at least one factor of h. But that being the case, once I cancel the h here and the h here, I will evaluate the limit, but since all these terms in here have at least one factor of h, they all go to 0. And the only thing left standing is that binomial. So what I've just proven to you is the following. To differentiate with respect to x a function of the form x to the n power, I will grab the exponent, bring it down to the level of everything else by multiplication, and reduce my exponent by 1. Now, I justified this on the other side of the board using my binomial theorem. That's why I had a restriction that n is nothing more than a natural number. Now, if you guys don't mind, I'm going to do a little bit of hand waving and suggest it still works if n is any real number. However, if you don't mind, I'm going to have to wait before I can actually justify that claim. But as of now, I have no more restrictions like I did on the other side of the board. Let's let n be any real number.